Hi, in a previous video, we have seen what are the 6 trigonometric ratios. So for any angle A, we have seen that the 6 trigonometric ratios are sine of A, cosec of A, cos of A, sec of A, tan of A, and cot of A. Okay, and we have also seen how do we find these trigonometric ratios if a right angle triangle is given to us. So let us understand this using some examples. So let us see example 1. Suppose there is a triangle ABC which is right angled at B. Okay, it is given that tan of angle A is equal to 4/3. And what you have to find? You have to find all other trigonometric ratios. Okay, now let us see how do we solve this. A very simple question. We know that tan of A is a ratio of opposite over adjacent. For angle A, opposite is the side BC and adjacent is the side AB. Okay, and it's given that tan of A is 4/3. This means that tan of A is the ratio of BC and AB and it is 4/3, which implies BC will be some multiple of 4 and AB will be some multiple of 3. Correct? Then only we'll get the ratio of BC and AB as 4/3. So we have got BC as 4K and AB as 3K. We know the two legs of the right angle triangle. Let us apply the Pythagoras theorem. Pythagoras theorem says that square of the hypotenuse is equal to sum of the squares of the two legs of the right angle triangle. So this is equal to 4K whole square plus 3K whole square, which is equal to 16K square plus 9K square, which is 25K square. If AC square is 25K square, then AC is 5K, square root of 25K square. So we have got all the three sides with us. If all the three sides are known, then we can find all the trigonometric ratios. So let us find them. Sine of angle A is opposite over hypotenuse, which is our opposite BC over the hypotenuse AC. BC is 4K and we have figured out AC as how much? 5K. So it is 4/5. We know cosec A is reciprocal of sine A. So sine A is 4/5. Cosec A will be 1/4/5, which is 5/4. Then we have cos of A. Cos of A is adjacent, which is 3K over the hypotenuse, which is 5K. So it is 3/5. And similarly, we can find sec of A as the reciprocal of cos A. So we get it as 5/3. So if all the three sides are known to us in a triangle, we can figure out all the trigonometric ratios. And since tan A is given, we know that cot A is reciprocal of tan A. So if tan A is 4/3, cot A is 3/4. Okay, this is the simplest question on finding the trigonometric ratios when one of the ratio is given to us. Let us see one more example. A triangle ABC right angled at C. Let angle B be theta. It's given that AB is 29 units and BC is 21 units. Okay, so AB is given as 29 units and BC is given as 21 units. We have to determine determine the value of cos square theta minus sin square theta. Okay, now here in this question, the important thing to note is cos square theta is nothing but finding cos theta and squaring it. And sin square theta is finding sin theta and then squaring it. So cos square theta is square of cos theta and sin square theta is square of sin theta. So first we need to figure out cos theta and sin theta. Cos theta is adjacent over hypotenuse. For angle theta, adjacent is 21, which is BC, and the hypotenuse is 29, BC over AB. So we know cos theta. Now our aim is to find out sin theta. What is sin theta? Sin theta is opposite over hypotenuse, but we do not know the opposite. So what we will do? We will apply the Pythagoras theorem. Okay, Pythagoras theorem says that to find this, we will apply the Pythagoras theorem. It says that AB square will be equal to AC square plus BC square in the above triangle. So we get 29 square is equal to AC square plus 21 square. So we get AC square as 29 square minus 21 square, which is, we can apply A square minus B square, A plus B into A minus B. 29 minus 21 is 8 and this is 50. So we get AC square as 400 and AC as square root of 400, which is 20. So what is our sin theta here? If we see sin theta, we have found AC as 20. So sin theta is 20 over 29. Okay, now we have to figure out the value of cos square theta minus sin square theta. So we will do square of 21 by 29, which is cos theta square, minus 20 by 29, which is sin theta square. Okay, so on simplification, we will get it as 41 over 841. This is the answer for the question. So what we have done, first we have figured out cos theta and sin theta. We have squared cos theta, squared sin theta and found their difference to get the answer. I hope these two examples are very clear to everyone. Okay, now one third example, very important one. Suppose it is given that sine of theta, for any angle theta, sine of theta is 4 by 3. Okay, for some angle theta. Is this statement true or false? What do you think? Can the value of sine theta be 4 by 3? Can we have a triangle in which for an angle the value of the sine ratio is 4 by 3? The answer is false. Sine theta can never have a value greater than 1. Sine theta can never be greater than 1. Why? Why sine theta can never be greater than 1? Let us see. We said that sine of any angle is equal to opposite to that angle, the side, and the hypotenuse. We know that. And which is the longest side in a right angle triangle? If we have a right angle triangle, then we know that hypotenuse is the longest side. Correct? This means that hypotenuse will always be greater than the opposite. And in a fraction, if a numerator is less than the denominator, then we know that the fraction is always less than 1. Correct? The same case we are having with sine theta. In sine theta, the numerator, which is the opposite, will always be less than the hypotenuse, which is the denominator. So it will always be less than 1. Correct? The question which is given to us is sine theta is 4/3. What are we seeing here? That the numerator is greater than the denominator. Is it ever possible? Can an opposite side be greater than the hypotenuse? No, it is never possible. So this statement is false. If you have any doubts, you can send me an email at kirti.mathacademy@gmail.com. This is my YouTube channel Math Academy. If you have liked my videos, you can subscribe to my YouTube channel for more such videos. Thank you.